Hi, I'm Amy Snover, Director of the Climate Impacts Group at the University of Washington, and I'm honored to have the opportunity to share with you some of the latest science around climate risk in the Northwest. I want to begin by thanking the Commissioner for the opportunity to speak at this event, and in particular, to thank all of you in the audience who are making time in your busy lives to pay attention to this really important and urgent issue of climate change. Our organization was honored to help partner with the Insurance Commissioner to host his first Climate Risk Summit in 2016, which was held at the University of Washington with about 150 people attending, if I remember correctly. I'd like to begin by introducing organizations I direct so that folks know what kinds of resources we have available in the Northwest for addressing climate impacts and climate resilience. The University of Washington Climate Impacts Group has been working since 1995 to build climate resilience across the region by advancing awareness and understanding of climate risks, and to work closely with folks to apply this information as they act to shape our region's future. We are also the proud hosts of two federal programs of cross-regional collaboration, also designed to build climate resilience: the USGS-funded Northwest Climate Adaptation Science Center, and the NOAA-funded Northwest Climate Resilience Collaborative. So in my talk today, I want to think a little bit about where we are now on our climate change journey, what's new from some of the recent science reports and observations, and a little bit of reflections on what the road ahead of us. Because of centuries of greenhouse gas emissions and emission rates that are accelerating over time, we're living in a world that's committed to significant climate change, disruption, loss, and damage. There is no doubt that we've changed Earth's climate through our activities, and with consequences for a broad range of aspects for the atmosphere, oceans, snow, ice, Earth's fauna, ecosystems, and all of us who live on this planet. We're on track to emit enough greenhouse gases to dangerously interfere with the Earth's climate system by the 2030s. We've already caused a little over 1 degree Celsius, or around 2 degrees Fahrenheit of warming, and we're on track to exceed the internationally agreed warming thresholds of 1.5 and 2 degrees Celsius if we don't get off the track we're on. Current estimates are for the end of the century, if we continue emitting serious amounts of greenhouse gases, to experience from 1 to 5.7 degrees Celsius, or roughly 2 to 10 degrees Fahrenheit of global warming. The really important thing to realize is that we will keep causing more warming until we reduce the global net amount of greenhouse gases that we emit each year to zero. Put more simply, until we stop emitting greenhouse gases, we will keep causing more warming and more warming and more warming. And so therefore, stabilizing temperatures at any level requires us to reduce emissions to net zero. We know a lot about the consequences of the warming that we've already caused and the warming that's to come if we don't reduce emissions now. And they're serious. And that's what I want to spend most of the rest of the talk talking about. So the science on key hazards and consequences of climate change in the world and in the Northwest has been clear for dozens of years. I've been working in this field since the mid-90s, have been given some version of this talk since then. And let me tell you, we know a lot, and we know a lot of detail, and we have a lot in hand to help us prepare. So we can expect climate change to bring us a significantly different climate here in the Northwest. We expect to see warming in all seasons. We expect more frequent incidences of extreme heat. And overall, we're really going to see ourselves moving outside what we think is normal. So by the 2050s, we expect that annual temperatures will be warmer than what we experienced during the past century. So let me say that again. The average year by the 2050s is going to be hotter than the hottest year of the 20th century. We also expect changes in precipitation, where summers are likely to be drier and falls, winter, and spring are likely to be wetter. We also expect that heavy rain events will become heavier. So for example, the top 1% of our heavy rain events would be 20 or so percent more intense late this century. All of this will bring fundamental changes to the water cycle that we depend on and that underlies life in the Northwest. The big change will be the effect of warming on our mountain snowpack. We know we depend on that snowpack for transferring water from the wet season of the winter to the dry season of the summer, holding that water for people and farms and fish to release it when we need it. The challenge is that warming will reduce the snowpack. And so depending on how much we emit, that snowpack is expected to decrease over time. So by the 2040s, we expect that spring snowpack in Washington will be about 45% less than it was in the past century, and about 65% less, or only 1/3 of what we expected in the past by the 2080s. Of course, individual years could be slightly better than that, and also slightly worse because of natural variability, which will also continue to layer on top of climate change. Overall, I would say the changes in the water cycle are making the drier times drier and the wetter times wetter. Or another way of putting it is more water when we don't need it. So increasing risk of floods, larger floods, less water when we do need it, increasing risk of drought, lower stream flows in the summer. We also expect more changes, significant changes in many of the Northwest forests. The National Climate Assessment a couple times ago, the third National Climate Assessment, identified changes, the combined impacts of forest fire, insects, and drought, combining to significantly stress and alter many of our forest ecosystems. Wildfire is on a lot of people's mind, and we expect to see the area burned by wildfire triple in the Columbia River Basin by the 2040s compared to what it was in the 20th century. And we also expect to see quite a few more very high fire danger days. So on average for Washington and Oregon by the 2050s, we'd see 50% more very high fire danger days. Sea level rise has already been observed and is expected to accelerate both globally and right here in the Northwest. So looking at the most recent projections for sea level rise in Washington state for the end of this century compared to the beginning, we expect that sea level will rise at Friday Harbor of around 2 feet, with a range of possibility of 90% chance of 1 to 3.5 feet. Tacoma is about the same, an increase of 2.5 feet. Could be a little less or a little more, depending on the confidence with which you'd like me to tell you that number. All of these things combine in the coastal area to increase risks of inundation, flooding, erosion. All of these changes that I've mentioned also compound to stress our ecosystems, fish, wildlife, habitat, our communities and social systems, and cause a variety of economic costs. In addition to the decades of climate science and climate impact science showing us what changes to expect on the ground, decades of climate impact and risk assessments have shown us what's at risk as a result of these changes in the Northwest. I'll just point out one of them here, which is the fourth National Climate Assessment, which was released in 2018. And the chapter on impacts on the Northwest identified these 5 areas of importance to the region that are most at risk from climate change. They identified our critical infrastructure, electricity, water, transportation systems at risk from hazards due to climate change, changes in temperature, and other effects, changes in demand that are caused by climate change. Climate change is also going to stress our natural resource sectors and economies in the Northwest. These range from forestry, fisheries, agriculture, and the communities dependent on them. Climate change will alter our natural and cultural heritage that underlies so much of what people value and experience here in the Northwest, whether it be tribal values of species or places, or recreational values of hunting and fishing. All of these will be stressed and altered by climate change. I think in this time right now, we all know how stressed our health system is, and climate change will bring increasing stresses through direct impacts on folks through like heat and floods and other physical hazards, to changes in disease and other impacts from that manifest for people in a variety of different ways. And then really importantly, the climate assessment pointed out the vulnerability of our frontline communities. And in particular in the Northwest, they identified tribes and indigenous peoples, natural resource dependent communities, and economically disadvantaged as on the front lines of climate change. So if you look across the sort of whirlwind tour I just gave of what we've known now for decades, the science, and then I'll talk a little bit more in the future about recent experience, but both of these are clear. Climate change will push on our sore spots, challenging our crucial aspects of Northwest life, economies, and communities, and come on the top of challenges and stress all of those places are currently experiencing. The Intergovernmental Panel on Climate Change released the 6th assessment report of the physical science of climate change. This release had the strongest statement yet about human influence on the climate, stating that human influence on the climate system is now an established fact. This reflects decades of science and assessments, studying how the climate system works, collecting more and more observations about changes around the planet, and basically watching the climate warm as human influence becomes stronger and stronger. So there is no doubt that we have warmed the atmosphere, ocean, and land, and that we're seeing the consequences now in numerous ways all around the planet. So people ask, what's new? What's new about this report? And what I would say is that in some regards, it's not new, because it's affirming and strengthening previous statements. On the other hand, that's very new, because what it is doing is showing us how the evidence is accumulating to enable us to be more strong about what we say. So CO2 concentrations in the atmosphere are now at their highest in at least 800,000 years. It's warmed over 1 degree Celsius, almost 2 degrees Fahrenheit, since pre-industrial times. And these changes in Earth's climate have happened everywhere on the globe and are unprecedented in human history. Humans have caused more rain to fall on Earth. Major atmospheric features like mid-latitude storms and the jet stream to move. We've caused glaciers to melt, sea ice to decrease, snow cover across the globe to decrease. We've caused oceans to warm, acidify, and lose oxygen, and sea level to rise. We've caused weather disruptions, meaning that we have changed what it is we should expect in terms of extreme weather events, where heat waves and extremely hot days have become more frequent and intense, and cold extremes have become more rare. We've started to see marine heat waves, which we've caused, which are regions of hot sea temperatures that have become twice as frequent since the 1980s. So climate change is already affecting every inhabited region across the globe. There's more specificity and confidence in the information that's provided in the IPCC and in the information we have available locally. We know that more greenhouse gas emissions will result in more warming. We know that every bit of additional warming brings bigger impacts. And we know that the total amount of warming and total impacts depend on how much we emit. The IPCC is being clearer, more explicit about warnings and more directly expressing urgency. They tell us that the land and ocean's ability to slow climate change by absorbing the CO2 from our emissions is diminishing. They tell us that many changes in our climate are irreversible for centuries to millennia. So even if we stop emitting today, we will see further global warming at rates that depend on how much we emit in the future. In other words, the Earth's climate hasn't quite caught up with all our emissions yet. And they are also very explicit in telling us that the changing climate means we can't base our decisions on what we've experienced in the past, but we have to take into account the scientific calculations for the future, because greenhouse gases stay in the atmosphere for a long time, and we haven't stopped emitting them yet. I want to talk now, turn from this conversation mostly about the global science and the global report to give a sense of what's new in our knowledge in the Northwest. And again, I'm really going to focus on the increased specificity of our understanding of what to expect, where, and when, and also talk a little bit about the direct experience we're seeing of relevant consequences. So I'm going to begin with an example about fire risk. We're increasingly understanding how climate change increases the risk of wildfire in the Northwest, and also how that risk differs in different kinds of environments across the Northwest. So in dry forests of central or eastern Washington, for example, fire typically has been frequent, small, kind of low severity, doesn't kill all the trees. Although some of those features have changed as a result of fire suppression. But fire tends to be caused by dry conditions, which are worsened by climate change. And we're seeing some of those worsen with the major fires we're seeing across the Northwest. But there's also good science about how to manage these fires, or how to alleviate the risk of these fires by prescribed burning and thinning. This is very different from what science is showing about climate impacts on fire risk west of the Cascades. In our large, wet forests west of the Cascades, we know that fire risk is driven by different features, that it's driven by dry conditions, ignition, and large east winds. We also know that prescribed burning and thinning is not sufficient, is not actually appropriate for managing this fire risk. And instead, we need to focus on prevention and preparation. So this is just an example of how we're understanding more and more what the local impacts are going to be, how they differ in different places across the region, and how appropriate preparation or response also differs. So this is the kind of information we need to embed in our local risk assessments and planning and decision-making. Another component of what to expect isn't just what the climate's going to do, but who's at risk and where and why. And so we're having increasing awareness in the context of fire of people exposed because they live in the wildland-urban interface. In Washington, about 35% of the housing units are in the WUI. And many of these communities are not adapted to the current wildfire risk, let alone the future. So we know what climate change will bring with this doubling of acres burned in grasslands, 4 times the acreage burned in forests by the 2040s relative to late 20th century. We know we're increasingly exposed and not prepared for current risks. And we're watching fires unfold across the landscape and show us the consequences of that preparedness or lack thereof. We're also having the opportunity to learn from that and see what kinds of treatments work and how communities can come together to increase their resilience and preparedness. Another aspect of wildfire risk, of course, is the increasing risk of smoke events reaching population centers. They've always been a hazard that's folks primarily in the drier parts of our region have experienced, but we've seen these more and more affecting larger populations in urban centers. We're having better understanding of the public health hazards associated with this and the need to increase support for coping options. During the last days of June this year, the Northwest, the Pacific Northwest here in the US and in Canada, experienced temperatures that had never previously been observed when a heat dome, which is a strong high pressure system, basically traps the heat and parks itself over us, happened. So records were broken across the region by huge margins. By a much larger margin than many of the climatologists or other researchers here in the region had ever seen in a heat wave. Canada set a new all-time temperature record of 121 degrees, I think, in the village of Lytton, which was largely destroyed by a wildfire that started shortly afterward. Portland had record high temperature of 116. Seattle recorded 3 100-degree days, as many as it did the entire last century. There are many impacts of these, the worst of which were the fatalities. Several hundred people were estimated to have died. There are wildfires, crop failures, transportation system challenges, slowdowns or closing of some of the transit systems in Portland, a long list of challenges across the region. These heat events in general are the form of extreme weather most likely to be affected by climate change. So this particular event was extremely unlikely to have occurred without global warming. Right now, with the amount of warming we've experienced, scientists have estimated that the risk of such an event happening in any year is about 0.1%. As we look forward, if we continue warming and emissions and the globe warms to 1.5 degrees Celsius, the risk would increase for an event like this from 0.1% to 20%. We know that the risks of heat events like this are not evenly distributed. And to make that point, I just want to share maps of the Seattle-King County metro area with a heat mapping project that King County recently did, showing how on hot days, heat is not evenly distributed across the landscape. Some areas are several degrees warmer than other areas, and this reflects actually long-lived patterns of inequities and discrimination in our communities. So we're not evenly exposed, which means we also need to prepare in different ways and provide preparation resources to those areas most at risk. So both at the global scale and right here in the Northwest, we are seeing events happen like our large wildfires, like the heat dome event, that are right along the lines of what we expect from climate change and are in some part or another caused by climate change. We've also have a long list of impacts that we can expect to unfold across the region. And building climate resilience means assessing the risks posed to everything we care about and working to reduce those risks. So I just want to spend a couple minutes talking about some of the resources that are available to support that kind of risk assessment, looking at a local scale about how the climate will change, what the impacts will be on the landscape, so that we can look at our own systems and see what we might be able to improve. This isn't an exhaustive list, but I'm aiming to give you an example of the diversity of information that we have, because it's sometimes easy to get lost in climate change being a huge issue, and it's not easy to remember that we actually have lots of really local specific data that can support decision making. So where are we now? We have decades of science on the impacts of climate change globally, nationally, and right here in the Northwest. We have decades of work by groups like ours and by communities and governments all across the region that help us understand really what's at risk. And we're at a place where more people and organizations are taking climate change seriously than ever before. We're living right now in a world where the human influence globally and locally is becoming increasingly obvious to, I'll call them ordinary people who weren't necessarily paying attention, or to people who thought this might happen, but it was all going to be a long way off. I'm experiencing that with the kinds of inquiries I'm getting, requests to speak, not just to planners or engineers or government officials, but I'm asked to talk in the media about climate impacts on tourism, on outdoor recreation, on urban planning. We've been asked to give talks to marine insurance industries. All of these folks are showing this, they're actually demonstrating how awareness and concern is at a level that I haven't experienced before in my career. And I know that the other talk on climate change in the American mind and opinions surveys is also showing that. We also see climate change being taken seriously by the executive orders coming out of the Biden administration, and by many things embedded in a lot of different proposed legislation from Congress. We're seeing climate change being taken seriously in our state by the passage of the Climate Commitment Act and a bunch of other legislation, by this summit and the acts of the insurance commissioner, by our state agencies starting to embed sea level rise information in their capital grant planning. The list goes on. We're seeing this nationally with Moody's, the credit rating agency, signaling bond downgrade possibilities for communities that are unprepared for climate change. We're seeing more action and more concern than I've ever seen before in my career, and we haven't done enough yet. And I say this with sort of three major aspects in mind about where we really need to step up our work. First, the National Climate Assessment stated, and I think many of us have seen this written in other places as well, that the scale of adaptation implementation is incommensurate with the projected scale of climate threats. In other words, awareness is at a higher level, risk assessment and planning has happened in many places, but we haven't made that step from planning to action. Climate is embedded in everything, everywhere, but climate thinking isn't yet embedded in everything we do. It's also very clear that despite significant progress at many levels of government in our region and across the country, frontline communities are facing significant climate resilience gaps. Climate change exacerbates and exposes fundamental issues of inequity. We have differential vulnerability and differential impacts of climate risk management activities. I see often that the capacity to respond or adapt or even think about climate impacts is concentrated frequently in wealthier and more urbanized geographies. And we have important resilience gaps that remain for many frontline communities across the region and the country. Finally, we need to do more because we haven't stopped global warming yet. We know that we will exceed the internationally agreed thresholds of 1.5 and 2 degrees C of warming this century, unless we make deep reductions in CO2 and other greenhouse gas emissions. So there's more to do. We need to implement our adaptation and preparation decisions using this locally specific science about impacts and exposure. We need to attend to the resilience gaps that are facing frontline communities, and we need to reduce and eliminate emissions so that we can stop warming. Thank you very much.